Okay, so this is going to be probably a little bit of a longer video, but if you need something in particular, feel free to skip ahead because I'm just going to kind of go through the different sections of this worksheet and do a couple examples, not from the worksheet, but of questions kind of like that and things you might want to think about. So the only thing I'm going to need here is, I have a scientific calculator. Really, a normal calculator, your phone will be fine. Mostly, we're just going to be subtracting and adding. So not too much to worry about. So the first questions here, we've got draw an angle with a given measure in standard position. So the key here is that standard position that they're talking about there. And so when we see standard position, the biggest thing we always want to keep in mind is where the initial side or the starting side of the angle is. So no matter what we're going to do, the starting side of the angle is going to be facing the positive x-axis. And then if we have a positive angle, it's always going to be going that direction. And if we have a negative angle, it'll be going that direction. And so if I start off with a positive angle like positive, let's say positive 325 degrees, what I really want to be keeping in mind here is that each of these is 90 degrees. So I've got 90 degrees, 180 degrees, 270 degrees, 360 degrees. And so I know that my 325 degrees is going to be somewhere in here. I don't need to be super perfect about where that's at. As long as we're in the right quadrant, we have all the information we really need out of these things. If I have something like negative 125, now I'm going down from here. And so, going backwards, now this would be like negative 90, negative 180, negative 270. And so negative 125 would be somewhere in here. And so we have our different angles of rotation. The biggest thing, or the hardest part of this is when we get angles that are over 360 degrees. So if I say something like I want an angle of 820 degrees, well, that's not on our normal 360 degree revolution. So this is where I'd grab a calculator. I'm going to make that a little bit bigger for you. And I just take 820 and I just start subtracting 360. So that's not less than 360, but that is. So I know I'm going to have to go 2 full revolutions plus 100 degrees. And so when I go to graph this one, since it's positive, I'm going this way. So 1 full revolution, 2 full revolutions, that's 90. So I know I'm just a little bit past there. So that right there would be about 820 degrees. If I saw something negative, kind of the same idea, if I had negative 610, for example, I'd go to, again, my calculator, negative 610, and I'd just start adding 360. Okay, negative 250. That's within my 360 degree range. So I know I'm going 1 full revolution and then 250 degrees more. So from here, going down now, 1 full revolution. Well, there would be negative 90, there would be negative 180, there would be negative 270. And so I know from my calculator, I'm looking for a negative 250 after I go that full revolution. So I'm almost to 270, just not quite there. So something like that. On those ones that are bigger than 360, I need to be able to see how many times you actually went around the circle. That's going to be the biggest thing I'm looking for on those, after you make sure you get it in the right quadrant. Next up, we've got coterminal angles. So when you see that coterminal angles, we're looking for angles that have the exact same ending position. And the whole key to these is that we want angles that are basically 360 degrees off of each other. So if I start off with an angle like 125 degrees, that would be about here. So there's my angle. I lost the color coding for you. Initial, terminal, there's my angle. The idea with these is if I were to go from this angle and just add 360 to it, I'd be right back where I was before. So if I would just go plus 360 and I'd get 485, that's a coterminal angle. The same thing would work if I wanted to start at this angle here. Like I've already got my 125, and now I just went backwards 360. And so there I'd be doing 125 minus 360. And that's where my mental math skills go away. So we get negative 235. So that would be another coterminal angle. So on all of these, to find a positive and a negative, you're just adding 360 or subtracting 360. Sometimes you might have to do it more than once. Let's say I've got an angle like 820 degrees. If I grab my calculator here and subtract 360, well, that's still a positive angle. And if I do it again, it's still a positive angle. So I need to subtract 363 times to get to a negative angle. And so any of these, 460 is a coterminal angle, 100 is a coterminal angle, negative 260 is a coterminal angle. So I could list all of those. So we found 100, we found negative 260. Those would probably be the best options. They are the ones closest to. But you could also add 360 to this and get a coterminal angle as well. Those are probably the easiest ones. I think this next set, where we're talking about reference angles, is probably the one that takes the most thought. These are a little bit trickier, especially when we get these ones that are more than 360. So first, let's talk about just a couple where they're less than 360. So I'm going to start with something like 210 degrees. That's a really common one we're going to see in the future. So 210 degrees. I have my initial side. To find my terminal side, I know, well, that's 90, that's 180, that's 270. So I'm past 180, but not to 270. So I'm here-ish. And for all of these, what my goal is to figure out what's the closest, or what's the angle measure back to the x-axis, the closest x-axis. And so here I'm looking for this angle measure there. I know this is 210. I want to get back to 180. Well, 210 minus 180 is just 30 degrees. And so 30 is my reference angle. In reality, what you're always doing here is you're either going to be comparing these angles to 180. How far is it from 180? How far is it from 0? Or how far is it from 360? So if I see something like 70, that's the real easy ones. There's 70 degrees. How far is it from 0 in this case? Well, 70 degrees. Or if I see something like 330. Well, that's almost a full turn, almost all the way back. So how far am I from being all the way back? Well, if this is 330 and I need to get to 360 to be all the way back, well, I'm 30 degrees away. So for all of these angles that are, less than 360 degrees, all it is comparing it either to 180 or to 0 or to 360. It's always going to be a positive angle. So even if we ended up with an angle like here, let's say it was 140, I'd be looking for this angle. From 180 to 140 is 40 degrees. That would be my reference angle. Where these get a lot harder, I think, is when we've got angles that are bigger than 360 or negatives. Let's just say we have something like negative 520. That is an angle that is all the way around plus some more. But in this case, since I'm just looking for the reference angle, I don't really care how many times I went around. All I care about is what's left over. So I've got negative 520. I'm going to add 360. That's at negative 160. If I really wanted to just make it positive, I could use the 200 degrees. That might even be easier. So let's do that. Let's take that 200 degrees. And I've just turned this problem, which I said is probably the hardest thing to do, into something that's really no harder than this. So I can say, okay, well, 520 is coterminal to a 200 degree angle. I can graph a 200 degree angle because there's 180. And I know I'm just a little bit past that. Well, how much is 200 past 180? Well, it's 20 degrees past. That's your reference angle. That's all we're talking about here. So it's probably easiest if you just add or subtract 360 until you get a number between 0 and 360. But, if you were ending up with a number like negative 160, you could do that too. There's negative 90, there's negative 180. So that angle would be there. Well, how far is it from negative 160 to negative 180? Again, 20, because those are all coterminal angles. Okay, and then the last part here, as long as you remember one little thing, these aren't so bad. So they give you the point, and the key to all these is remembering that we want the reference triangle back to the x-axis. So if I get the point 3, negative Let's do a different one. Let's do something that doesn't come out so nice. We'll go 5 comma negative 7. So on my graph, 5, negative 7 is 1, 2, 3, 4, 5, and then down 1, 2, 3, 4, 5, 6, 7. So right there, there's my angle. It's actually this angle, but we want to use the reference angle from 0 or from the terminal side back to the x-axis. And we create a right triangle out of that. Anytime we're doing this, that's the goal, is create a right triangle. And these coordinates are going to tell us the two legs. I know I've gone over 5, and I know I've gone down 7. So those are the adjacent side. That's the adjacent side. And then that's the opposite side. We just need to find the hypotenuse by using the Pythagorean theorem. 5 squared plus negative 7 squared equals c squared. So I've got 25 plus 49. This is where I stop and say, just use a calculator. So 74. And we're going to square root 74. This would be also a good time I should check to see, does 74 have any perfect squares that go into it? 9 doesn't work. 4 doesn't work. 16 definitely isn't going to work if 9 didn't work. 25 isn't going to work. So it doesn't look like 74 has anything that goes into it. So this is simplest radical form, square root of 74. And so now the questions are going to ask, well, what is the sine of theta? What is the cosine of theta? And what is the tangent of theta? And even though this green angle that I marked is technically theta, what we're actually using to define sine, cosine, and tangent of this green angle all the way around, we're using the reference angle. So from this angle, we define sine. Sine is opposite over hypotenuse. So it is going to be negative 7 over the square root of 74. Now, if you look at the directions here, it says find the hypotenuse and the three trigonometric ratios in exact form. Simplified, rationalized fractions. We haven't rationalized this fraction yet. So that's what we have to do. And this is something we talked about quite a while ago, but just as a quick reminder, all you have to do to rationalize a fraction, which means to not have a square root in the denominator, is just multiply by that square root in the denominator and in the numerator. In the numerator, the top, we have 7 times root 74, so negative 7 times root 74. And in the bottom, root 74 times root 74 is 74. Then we would check to simplify. Does anything go into 7 and 74? No, it does not. So that is simplified. With the cosine, we'll do the same thing. Cosine is adjacent over hypotenuse. So the adjacent is 5. So it is 5 over root 74. And I bet you can kind of guess how this one's going to turn out. I'm going to multiply by root 74 on top and bottom. On the top, I'm going to get 5 root 74. And on the bottom, I'm going to get 74. And you're going to see that these almost never actually simplify. If it would have simplified, chances are it would have simplified the square root first. And then the tangent is always the easiest one here. So the tangent is opposite over adjacent, so negative 7 over 5. And there you go. That's about as hard as these get. So hypotenuse with Pythagorean theorem. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then the last chunk here at the end are your applications. So for these, what is really important to try to figure out is the relationship between degrees and what they're actually talking about here. So in this case, the key here is we make one full rotation every hour. And so that's how we're going to kind of keep all this in mind. 1 hour equals 360 degrees equals 1 revolution. So when we start seeing things like 30 minutes, well, 30 minutes is just half an hour. So that means we're going to go 180 degrees in 30 minutes. If we see something like even 5 minutes, well, 5 minutes, 1 hour is 60 minutes. 5 minutes, well, that, 5 minutes is going to go into 60 minutes. What is it? 60 divided by 5. That shouldn't be that hard. 60 divided by 5. 12. Goes in 12 times. So that's going to be 1/12 of that. Since it's 1/12 of an hour, it's 1/12 of 360. And so 360 divided by 12 gets me 30 degrees. So 5 minutes turns out to be 30 degrees. 10 minutes would be 60 degrees. And we can just kind of come up with this ratio here. It's just a fraction of the time gives you a fraction of the degrees. If you had 2 hours, well, that's 720 degrees, or 2 revolutions. And so you can just kind of work your way through how much of a revolution, what fraction of a revolution are we talking about? This is half of an hour. This is a 12th of an hour. This is a 6th of an hour. This is 2 hours. And so it's the same fraction of 360 degrees. So really, the math you're doing here is never really that bad. It's usually just what fraction of 360. So if it's a half of 360 or 2/5 of 360, something like that. But really just the key is, are you reading the question? Are you understanding what fraction of a full revolution you're going to go through? Okay, so you got, like I said, today to work on this. The answer keys are all on the Canvas page and in class. Work together, and on Monday, we can go over any questions before we start talking about radians.